Classical question, what is AI? And I don't mean what does the abbreviation stand for, I mean what are we actually doing here? Is it a science? Is it an engineering discipline? What is it, if anything at all? So, in 2013, we have more than 60 years of AI research, if you start counting with Turing's computing machinery and intelligence. Still, AI is kind of different, at least it feels kind of different than most of the other sciences. Partially visible and okay, maybe you will contradict me, but I think there is not even agreement upon what shall be AI's overall objective. So what do we want? Do we want soft AI, strong AI? Do we maybe want a bit of both? Is it super intelligence we are directly aiming for? Is it general intelligence, which is not necessarily human style? Normally, at least in my experience, when you assemble 5 of us, you have at around 7 opinions on these topics. So also there's no commonly accepted methodology. There are symbolists, there are connectionists, there are people doing something else. And there is not even consensus concerning the valuation of previous developments and the actual status quo in AI. So is it actually a success story? Is it a story of perpetual failure? Yeah, there is no one opinion, which actually makes wonder, is AI maybe a special type of science, or is AI a science at all? For what I'm talking about now, I'm focusing on human-level AI. Occasionally I might call it AGI, but what I really mean is human-level AI, just to clarify the notions. Nick Cassimatis, in the Advances of Cognitive Systems journal, lately had an article called Human-Level AI Must Be an Extraordinary Science, where he basically states that normal scientific standards and methods are often incidental and even antithetical to achieving human-level AI, and that a different approach would be required. In what follows, I will mostly always give 1 or 2 of Nick's arguments and positions, and I will present my reply to them. So, the first part of his basic positions is that there is a significant qualitative difference in specificity and level of ambition between research in HAI and other sciences. So, according to him, our objectives are more concrete and much more ambitious. Also, he claims that HAI historically was not conducted as a normal science. So, if you follow his argument, systems like Schrödl and all the other systems of the forefathers allegedly did not witness experimental evaluation or any formal proofs as obligatory part of science or engineering would require. This is the part I'm only quickly gonna reply to. Concerning the level of ambition and specificity, I guess that's up to everybody to judge for him or herself. Like, what's more ambitious, creating intelligence or following the goals of physics and trying to understand the universe at every possible level? Everyone judge for himself. But concerning the second claim, the scientific standards of old AI, first of all, directly going back to Schrödl, Winograd already tested it even in his PhD thesis, and he did benchmarking against other parsers, he did benchmarking against human participants, so there is clearly metrics and there is evaluation. And at the same time, if you then, for example, have a look at Newell and Simon's General Problem Solver book, there is an appendix which features lots and lots of interviews and introspection interviews they conducted with human participants. They rigorously, well, now we would say they rigorously had a procedure for doing it. They collected data, they evaluated it in a formal way. That's precisely what some parts of psychology, like problem-solving psychology, still does. This is, in my opinion, scientific standard. So I would actually align with Russell and Norvig, where in the last edition, at least, of the AI textbook, they state that in terms of methodology, AI has finally come firmly under the scientific method. Back to Cassimatis. The first part of his paper is about that the application of scientific norms and methodological standards is not favorable for achieving HAI and often stands against swift progress towards this goal. First of all, he has kind of an attack on formal and empirical demonstrations of correctness or optimality, and as well on the connected computational requirements in terms of processing power and speed. So he criticizes the belief that importance should be assigned to showing formal correctness of a theorem or to empirically demonstrating methods optimality with respect to a certain normative standard, as in his view that goes against the nature of human intelligence. He there as well brings into the field Simon's notion of bounded rationality, as he says that, okay, humans fail normative standards, so AGI also should not use normative notions of correctness or optimality in judging and evaluating results. In my opinion, the problem does not reside with optimality considerations per se, but it resides with the standards you choose. Okay, if you say your rationality standard is classical logic, admittedly, humans fail it. Clearly, have a look at a Wason selection task. And at the same time, coming back to something I already commented before during the Q&A, I also don't see the point that human cognition automatically would solve difficulties arising from the type of problem, or would solve problems with tractability and with computational complexity. Still, I think that quantitative assessments are a necessary core part of psychology and should as well be a necessary core part of AI. Namely, there is a form of AI called psychometric artificial intelligence which already applies this paradigm. Their basic idea is that some agent is intelligent if and only if it excels at all established validated tests of intelligence. You just apply the same standards you would apply to a human in all the battery of intelligence tests to your HLAI. Then Cassimatis continues, and he has quite a struggle against empirical cognitive psychology and neuroscience, as he says that, okay, they adhere to normal scientific standards and methodology, and they rely on experimental studies of mostly isolated individual capacities and functions. According to him, this would inevitably not be aligned with the standards needed for HAI, because in psychology, the phenomena studied are very often not directly crucial for progress towards solving the overall intelligence puzzle, but would focus on individual bits and pieces of it. And secondly, what psychology does, because, well, studies are normally not conducted with a single subject, but are averaged over a population, well, you average over a possibly high number of subjects in your experimental evaluation and thus abstract away from the individual, which, according to Cassimatis, provides general decontextualized average predictions of behavior of cognitive systems, but is not contributing to solving the intelligence puzzle at the individual level. Okay, by themselves, these observations are correct, like that is what psychologists do, but I think they are good in doing so, because cognitive psychology significantly differs from differential psychology in methods, results, and ambitions, but the insights gained in cognitive capacities on a general level are as valid to HAI as insights on an individual level. First of all, I know that is trivial and that is not overall true, but still I think it kind of proves the point. Each average trivially corresponds to one subject, namely the average subject. Unless we are dealing with something which has a bimodal distribution, we normally have someone who perfectly matches the average person. And also, an average prediction normally can be bootstrapped into an individual prediction by contextualizing it with the initial and site conditions. So, I would advocate to actually go along with the approach of cognitive psychology and of psychometric AI, thus, in staying under the umbrella established by scientific standards, because we can get quite some advantages out of this. So, quantitative and comparative methods allow for measuring and judging progress. So you can say, well, what I just implemented gets me closer to performing on the intelligence test battery as a human would. And also, actually, you can explicitly specify when you have a breakthrough, or you can explicitly set yourself milestones you want to meet. You just have a measure of progress. Concluding, what I actually would advocate is a strong necessity of viewing human-level AI or artificial general intelligence as a normal science and to apply rigorously scientific standards. We can and we should rely on quantitative and comparative experimental and, well, as well formal methods whenever possible. if you can get an evaluation of your system, and if you can evaluate it against humans, if you want to do human-level AI, I think that's the standard you have to beat and you have to meet. And finally, well, human-level artificial intelligence must be a science, at least asking me. Okay.
Because I study philosophy, I still feel a bit hurdly about your position. I think I understand your motivation. We need some thank you. And we need some scientific standard and to get AI study constrained by those scientific standards. That's right. But engineering job, I mean not science, they are also constrained by those very strict scientific methods. To be a science requires something more. For example, there is a big difference between test and experiment. In normal science, we need experiments to falsify or support a hypothesis. A hypothesis is intended to explain some phenomena. So if we want to say HAI is also a normal science, the first important thing is there should be some phenomena, a dollar of phenomena to be explained. Then we make hypothesis. But the first thing is what we really do is to establish different cognitive models to do the job. It looks like engineering because it is not a phenomenon, but that is a commonsensical standard that we need to approach. I think that is something different from. Another thing is in normal science, we always talk about in which degree a hypothesis can support to explain some kind of a given phenomenon. And in many cases, we have a very precise way to tell whether the prediction can go or not. For example, the prediction is in mathematical language, and the experimental can also give some data also in mathematical language, and we can match the both. But the problem is here we're talking about HAI. Of course, we can introduce some precise way to measure it. But I'm afraid that different people with different intuitions will give different standards to measure that. So it's very hard to have some commonly shared standard compared with science. So this is my personal.
Yeah, okay, I do see your point. Still, I maintain that actually your position is not as commonsensically accepted as you actually assume. And secondly, I would just like to argue with cognitive psychology and computational level theories. So, of course, you can now debate whether psychology is a science in the strict sense, as very often it's conducted theory-free.
This is true.
That's yeah, but if you now grant psychology the status of a science, I would say that we should try to adhere to the same standards. So we should as well try to have valid theories grounding our research and our work. In my words, it would be computational level theories, and in my words, talking about human level AI. So talking about an AI that tries to meet a human in his or her intelligence level. There is all the battery of psychometric psychology, which we can carry over to psychometric AI. So there are normative standards. The question just is how to bridge the gap between the particular cognitive theory and computational level theory to the broad range of psychometric intelligence. That's true, yeah.
Well, I have a response. Yes, of course, cognitive psychology is a science. I think most people will believe that. But if you want to prove to support a hypothesis in cognitive science, in most cases, we will appeal to neuroscience to offer the data. For example, if some philosophers like Jerry Fodor say there is modules in the mind, is the thesis of modularity true? We will find how modules are realized in the structure, neural structure. Just because the domain of cognitive psychology is very clear, they are talking about a human human intelligence or something like that. But there are some problems for HAI. The first problem is human intelligence is just one instantiation of intelligence in general science. We do not have explicit instantiations of others. So dominant is not very clear. This is because there are other, the God intelligence, if you believe Christian belief, or alien intelligence of angels, dolphins, there are other things. The second is more philosophical troublesome. That is, I think the philosophical position of HAI is functionalism. You believe that there is a more abstract level above the neuroscientific level. But most scientists will believe that there are different algorithms which can do the same job. Just like last evening's talk, Ben and John, their group, they talk about even a symbolic network can be transferred into a connection network. They can do the same job. So maybe they can have the same outputs. In this way, we cannot decide which is better. But if we reduce to the neural level, it is more clear.
Okay, quick reply. First, like your first point about different forms of intelligence, that's the reason why I precisely narrowed in on human level AI. So I'm dealing with the human phenomenon, leaving animals, leaving other forms of intelligence aside. Because then I know that this is a dodgy definition, but it is a definition. Intelligence actually is what intelligence tests measure. So it is dodgy, but it is. On the other hand, I'm fully guilty of being a functionalist. Yes, I admit to it and I love it. And this is where computational level theories come in. So I don't care about the implementation level. I don't care whether you run it on a distributed neural network or if you run it on a theorem prover. As long as your computational level theory is precisely defined, there shouldn't be a difference between the both, because running it is at best algorithmic and normally implementation level. And final remark, the explanatory power of neuroscience when it comes to cognitive capacities is, in my opinion, at least questionable, because there you have the opposite gap. You see where the brain lights up. You might even be lucky enough to get a bit of a firing pattern and frequency, but how it scales up, like binding problem, like all these things, we got no clue. So you just go in a circle. You reverse the problem, but you don't solve it.
Okay, I'm sorry, but I have to interrupt us now. Thank you very, very, very much.